All right, hello everyone. Welcome to Web Hacking 1. Sorry for the delay. We're having some AV issues. Thank you for finding Lewis 141 on such short notice. We just got our room reservations in yesterday, and I can say that we don't have a consistent location, at least not for a bit. So make sure to be checking Discord for when or where we're exactly will be meeting. But at some point this semester, we'll start going to 1404 and we'll see us regularly. But for now, it's a little bit all over the place. So first, really important, definitely join Policy TF 2024. So we just opened up signups. You can go to SIGPwny.com/PolicyTF. Hopefully that link works. And that should take you to the page, and then you can also there should be a button to register and fill out a Google form. We do ask that if you are considering going, please sign up, because we use this to determine how much pizza to get, how many shirts to buy. So it's super important that you sign up. But it's going to be fun, and we'll see you there.
Great, yeah, so this is the meeting flag. Everybody try to get this in, suggest@sigpwny.com. And yeah, I'll be talking to you about web today. Okay.
Hi, Mama.
All right, and yeah, I just want to emphasize, please do come to Fall CTF. It's beginner friendly, no knowledge required. That's like pretty much how I got started with this. So yeah, come with, please. All right, we'll come back to this later if you didn't quite get the chance, but just due to the delay, I'm gonna skip past those. So, all right, today I'm going to be talking about how websites work. So specifically, like how HTML, CSS, and JavaScript kind of act as the brains of a website. Sorry, respectively, the bones, skin, and brains of a website. And then we'll talk about how you interact with websites using the web, and how your browser acts kind of as a client to interact with web servers. So talking about that client-server model. Then we'll talk about how web apps can store state using cookies and local storage. And finally, we'll talk about how you can sort of start to poke at some of these internals of the web apps using Chrome DevTools, and we'll walk through some of our challenges. So first, let's talk about how websites work. So the three important languages that define how web apps work are HTML, which sort of acts as the skeleton of a web app, CSS, which is the styling of web app, and JavaScript, which allows you to add logic and interactive aspects to web apps. So first, HTML, it's sort of like the bones or skeleton of your website. It defines the layout and structure of a website, which includes things like, in our example, the images, maybe some buttons, text boxes, or even forms. So specifically in our example, we have like this text, hello world, defined in the HTML, which shows up on our web page there. And we also have the image of a cat. And then lastly, we can also define other things like scripts, which can add interactivity, which we'll talk more about later. So now CSS, which is sort of the skin or styling of a website. So CSS defines how elements look, and this is what you'll see designers spending a lot of time just tweaking to make sure everything looks just right. And then it can be written either inline into HTML, or more commonly, it's loaded from a separate file. So in our example, we can see by adding these two rules, we've rounded the cat image, and we've also added a shadow around the image, which defined on the left. All right, so finally, which is sort of acts as the brains of the web, is JavaScript. So this is how we can make web apps interactive. Before JavaScript, we could do things like have forms and display information, but really to like bring our web apps to the next level, make them more interesting, we need to add scripts. So for example, we could write code that would like maybe send data to our server when we press a button. Once we get a response back, we can do some logic and then show something. And then more simply in this example, what we've done is when the user clicks on this cat image, we'll display an alert, meow, which we show there. So now we'll talk about how you can actually get these web apps delivered through the web. So first, let's talk about the client-server model. So like when you interact with the web, you use a browser like Chrome to visit a website, and it'll ask it for like, let's say, the index website, right? Like if you just go to example.com, and it'll make this request, send it off to the server. And then the server will give us back that HTML file that we kind of discussed earlier. And once we have the HTML element, file, it might define some more resources that we need. So like in our example, there's that cat image that we need to get, right? That's not actually in the HTML file, it's just a link. So then we need to request that from the server again. And it'll send us back the actual contents of the image. And then also if we had like a script, we could also request that from the server and then respond with some code. So I'll talk about how we can start to add some state to our web apps to make them more useful. So the first mechanism for this is called cookies, which are small pieces of information that are stored across the Visto website. So the way that you get these is the server sends them to you with whatever you've requested, and then you'll persist them, you'll keep track of them until you get rid of them later. So the main usages are like they can maintain a session on you. So like when you log in, you're still logged in, even like if you refresh the page, go to other sites. And also for like advertising, it's useful for tracking. So this is kind of expanding our client server model now with these cookies. So let's say when you request index.html, you want to attach a cookie to you. So we'll send you that. And then along with the response, we'll tell you, hey, now we have a cookie for you to store. And then when we go somewhere else, we'll send that cookie, the exact same cookie, back to the server with our request. So now another mechanism for storing state on the web is called local or session storage. So these are similar to a cookie, except you're not just sending them and receiving them over like the requests to the server. You're actually managing these now with JavaScript. So it's like a key value pair. So you see the key just meaning this is what we use to define the entry into our table, and then the value. So once we set something in local storage, let's say the key is SIGPwny. When we get that item called sig, we'll get the value string pony. So local storage persists indefinitely. That means that JavaScript doesn't have to worry about this going away unless it specifically deletes it or like if the user clears it. But session storage is only persistent until the browser's closed. So this is kind of a shorter term storage. So now we'll talk about some tools.
All right, so I'm going to be talking about some of the tools that you'll be using, especially for today's web challenges. So
Yeah, you can click on the down button on it.
all right, sorry, starting just here. Let's see. So the first thing we're kind of going to look at is the dev tools. Actually, that's where most of the tools we'll be looking at today is. And you open this just by using the Control-C or right-click and select element, and that's where a lot of the HTML of the page is going to look like as soon as you open it. So then you're gonna have the HTML code, and you can also see how that kind of interacts with your JavaScript and CSS. So as Jay kind of mentioned, the JavaScript has the event listener, so that's a lot of the code in the page, and then the CSS, of course, the styles. So you have also the styles pane, which has more of the CSS attributes. It should be either on the right hand side. I know on Microsoft Edge, which is what I use, is on the bottom. But all this HTML content can be modified. So you might have played around with that before, where you can just change any of the text and then it will just show up differently on the website. But once you refresh it, it's going to all be gone. So we move on here. We can look at the console, and all this is up on the tabs that you can see in the little image up there. Originally, when you open it up, it's going to be on the Elements tab, but if you switch tabs into the console is where you're going to see this next kind of image here. And you can view all the errors inside the JavaScript command line. And then you can also just put in any JavaScript code you want. So here we have the console.log, hello from the console, and that's just going to output that into the actual console here, if you see up in the image. And then here in the console, you can also make pop-ups and just in general run any code you want. We move on. So the third kind of tab we're going to be looking at in the DevTools is the network tab. It's a pane that tells us the content you're currently seeing, like how did that get to the device? And when you visit a web page, your browser is going to make a lot of requests to get whatever data you need. So on very simple websites, it could just be one request where you just get the HTML file. But usually for a lot of the websites that we see nowadays, it's going to make a lot of different requests. And that's going to be loading all the images, anything, files, scripts, all that is all being loaded up. And if you refresh it, you can see that all of these like requests will show up and you can click on any of the requests and there should be a request a header section and it will show you what the browser sent to the server. As you saw in the server client model. So you can also see login forms, file uploads, etc. Okay, and then the last thing we're kind of looking at in the DevTools, there's a lot of different tabs, but this is kind of the last relevant one for today. And it's going to be the application pane. So it's also called differently depending on what browser you use. But here's where we're going to see the cookies and local/session storage. You can view the values, you can edit them, you can delete them. So anything that's really relies on client side, like cookies for security is going to be really weak because if you kind of play around with it right now, you can see that you can go ahead and delete, edit any of those. So finally, we're going to talk a little bit more about like the server side versus client side. So as you see, like on the model, you're going to have requests sent to the server and the responses sent back. But any changes you use isn't going to actually affect like your server. So it's, everything you do is client side right now. So if you see here, any DevTools, anything you change within DevTools is going to change within there. So how do we kind of access the server side? So this will be expanded upon a lot more in future web meetings. So if you come back next week, Web 2, I think they're going to talk about it a lot more. But just as a note for right now, the challenges we have is going to be anything that is like visible in the HTML source code. You can kind of change it around and maybe affect any of the JavaScript that hides the information that you're trying to see. And there's also, for, I guess this is going to be focused on Web 2, but the sites sometimes rely on the clients to send like the right requests. And if you send maybe some requests that they're not expecting you to send, then you can often cause these sites to crash or leak any information. Okay, so do you want to cover the next meetings? Yeah.
Wow. We love microphone noises. All right, so this Sunday, we're gonna be expanding upon what we talked about here. We're going to web hacking 2. And what Emma was talking about, with the server side stuff, we're gonna get more into that as well. Next week on Thursday, we're gonna be talking about OSINT. That's one of my favorite topics. It's gathering information from open sources. It's pretty fun. And do not forget about fall CTF. There will be free pizza. There will be t-shirts. You should sign up so that there will be enough t-shirts and pizza for everyone. And if you want to learn more about hacking, have a good time hacking with your friends, please come to fall CTF. It's a great time.
Yeah.
Those are all challenges. Please.
All right.
And if you guys need any help with any of the web challenges, feel free to raise your hand. We have some helpers in the crowd who can come help you solve challenges. Again, if you go to ctf.sigpwny.com, did anyone, was anyone able to submit the meeting flag or not? There's a chance that challenge can happen. Yeah. You submitted it? All right, we're good. Okay. So yeah.
It was kind of when the meeting started, I.
All right, so thank you.
Oh, she's on the cross. Oh, yeah.
Also, if you are interested in purple team at all, we will be having our intro to blue team meeting at 7, right after this. So feel free to stick around for that.
What? Oh, zoom in, control plus. Yeah, all right, let's zoom in.
Wrong place, but. Or you want, it'll be fine.
Yeah, I was kind of thinking about why I use Chrome. Yeah, so if we, wait, I'm not familiar with Firefox DevTools. 1 second. Wait, I'll open this like sources.
Go to style editor.
Style editor? Okay.
Or I'm sorry.
Oh, okay.
I'm a liar.
All right. So
Yeah.
this would be like sources in Chrome DevTools. So, okay, we're not interested in your extension. All right, so what we are interested in is this script.js. So what we'll see is flag 5 is this function here, where we have this weird expression that's then subsequently overridden. So it seems like maybe what this variable is assigned to up here might be useful. So one thing we can do, again, is we can set what's called a breakpoint here, which means that when this function is executed, execution will be halted. And the debugger will allow us to inspect the variables at that time. So if I call for 5 again, oops. You see we got pause. It's really small, but it says it's paused on a breakpoint up here, which means that the execution has been paused. So what we can do here is we can actually inspect the state of the variables. So at this time, flag 5 is not assigned because this expression hasn't been evaluated. What we can do is we can step over this evaluation here. Oh, wait, why is it halted? Okay, no, sorry. Now it finally executed. And what we can do is see that flag 5 has been set to this string. So basically what this does is it's kind of cursed, but it obfuscates the JavaScript code by just using a few characters, which eventually end up building up this string, which is flag 5. So if you need help with this challenge, let me know and I can walk you through that. Wait, why did the debugger use feelings again? Should we make one more demo before we like cut out? Yeah, where's the Alright, before everybody heads out, we're gonna do one last demo. So this is gonna be for inspecting 7. So I'll just refresh the page here. So I'm kind of struggling to hold the mic and do stuff. All right. Wait, where's the dev console? All right. Apparently I just can't hit the buttons correctly today. Anyway, yeah, so what we're gonna look for flag 7 is in the network tab, which we talked about earlier. When we refresh the page, you can see all of the network requests as they come in. So ignoring the breakpoint that we've just set, we can look at everything that the server has sent us related to this request. So specifically, we might notice that the response headers have this interesting header here, which is the flag. So if you're actually attacking an application, looking at these response headers might be useful because you'll see things like a server version use, which might allow you to target certain exploits. And then also just generally understanding like what exactly the server has given you beyond just the contents of the response.